In this video, I will discuss the raster model. Raster data models represent reality through grid cells in an image file that are given attribute values. The cells are formed into rows and columns to represent the entirety of the area. They are most often square and evenly spaced. The model is continuous, but it can also represent discrete values. So when I say continuous, I mean that there are no abrupt transitions like in the vector data model. Because of this, raster data is most often used for variables that change continuously across a region, like elevation and temperature. The cell coordinate is usually the center point of the cell, and the cell value is applied to the entire area that the cell covers. If the entire area is uniform within that cell, then that cell is completely accurate. However, if it's not, which is much more likely, there is what is called within cell variation. And if the values vary within the cell, the value is represented as the average, median, mode, max, or minimum value. Usually the average, the median, or the mode though. There is a big trade-off between spatial data detail and data size in raster data sets. A minimum of 4 cells are required to locate a feature or a specific value, so the largest cell size you would want is half the size of the object you're trying to locate. Having a smaller cell size is advantageous because it gives you more detail, but it comes at a price. The number of cells needed to cover a given area increases 4 times when the cell size is cut in half. Smaller cells provide greater spatial detail, but it can cause the data set to increase significantly in size. That not only increases the amount of space it takes up on your computer, but also drastically increases the amount of time the data takes to process.